At the end of the previous lecture, I mentioned that there are different ways to generalize approval voting, and one of those ways is to ask the voter to submit both a ranking overall of the candidates and the candidates that they approve of. So in this lecture, I want to look at methods that do that. And in particular, we're going to look at a method invented by Stephen Brams and Ramsey Sanver in this article, Voting Systems That Combine Approval and Preference, that does just that. So preference approval voting, it asks the voters to rank the candidates from their most preferred to their least preferred as usual. No ties are allowed. But it also asks you to specify which candidates you actually approve of. And naturally, we're going to make a consistency assumption that if you approve of a candidate, then you approve of all candidates ranked above that particular candidate. So with this consistency assumption, we can represent the voters' ballots in the following way. We can introduce this special symbol star, and that's meant to be a line between the approvals and the candidates that the voter does not approve of. So in this example, the voter ranks A above C, above B, above D, and approves of the top two candidates. So how does preference approval voting work? So it works in the following way. You first try to figure out which of the candidates receives a majority of approvals. So what that means is a majority of the voters, strictly more than half of the voters, approve of that candidate. Now, if no candidates receive a majority of approvals, or exactly one candidate receives a majority of approvals, then the candidate that would win under approval voting, namely who gets the most approvals overall, is declared the winner. However, if there's more than two candidates that receive a majority of voting, then we have two cases to consider. The first is that we look at all of the candidates that receive a majority of approvals, and we try to figure out if there's one candidate that beats every other majority approved candidates in a head-to-head election. So this is kind of a Condorcet winner, but only among the majority approved candidates. So if that Condorcet winner exists, then elect that candidate. If not, what that means is that there's a cycle among the majority approved candidates. You elect the candidate that receives the most approval among the most majority approved candidates. So it's a little bit of a complicated system, but let's look at an example to illustrate these two situations. So first of all, here's our example. There are 7 voters altogether, and everybody approves of their top 3 candidates, and they have these rankings. Now note, candidate C has unanimous approval support. So that naturally C would be the approval vote winner. So the question is, what about C? Would C be the preference approval vote winner? Well, let's see. Note that A, B, C, and D all are approved by a majority of the voters. So there are 7 candidates. If you're approved of 4 or more by 4 or more voters, then you're approved of by a majority. All of A, B, C, and D are approved by 4 or more. So A is approved by 4 candidates, C is approved by everybody, B is approved by 5, and D is also approved by 5 candidates. In fact, candidate A has the least number of approvals. A actually has the fewest approvals overall. However, according to preference approval voting, according to the rules of preference approval voting, candidate A would be declared the winner. So why would you think that A should actually be declared the winner? Well, note that candidate A actually beats all the other candidates in a head-to-head election among the majority approved candidates. So compare A versus B. Note that 2 people rank A above B. So 2 people rank A above B. And then how many people among the majority approved candidate ranks B above A? Well, if we look at all of these lists here, 0 people rank B above A. Nobody among the majority approved candidates ranks B above A. Of course, 3 people in this column do rank B above A, but they don't approve of A. So what preference approval voting does is it actually ignores that data. It's as if everything below this star line is not actually represented. So a majority of people, 2-0, more people prefer A over B than B over A. So I shouldn't say majority here. I should just say more prefer A over B than B over A. What about A versus C? So again, we have 2 prefer A over C. So 2 prefer A over C, but 0 prefer C over A. What about A versus D? We see that 2 people prefer A over D, but nobody prefers D over A. I think I made a mistake there. Actually, we have 4 people prefer A over C, but nobody prefers C over A. So A beats everybody else in a head-to-head election among the majority preferred candidates. So preference approval voting ends up electing a candidate that actually has the fewest number of approvals. Now let's look at a second example that uses what happens if there's a cycle among the majority approved candidates. So again, in this example, candidate C receives unanimous approval support. So C is approved by all 8 voters. So note I've changed the example. So there's 8 voters overall. There is a top cycle among the majority approved candidates. So again, note A, B, C, and D all have a majority of support. So D has 5 approvals, A has 6 approvals, and B has 5 approvals, and C has all 8 approvals. So all of that is strictly more than half of the population. So everybody has a majority of approvals. Now, note that everybody ranks A, B, and D above candidate C. So preference approval voting wants to register that fact, which is why somebody that has unanimous approval support is not going to be elected. So it must be one of the candidates among A, B, and D. So now what we want to do is we want to figure out in the head-to-head elections which of A, B, or D has the most support. But note what happens is 3 people rank A above B, but nobody ranks B above A. So A is ranked above B. 2 people rank B above D, but nobody ranks D above B among the majority approved candidates. So B is ranked above D. And 3 people rank D above A, but nobody ranks A above D. So there's a cycle. There's a cycle among the most approved, majority approved candidates. And so what do you do in that case? Well, what the rules tell you is that you elect the candidate that receives the most approvals among the candidates left in this top cycle. In this case, it's candidate A because A receives 6 approvals, whereas B receives 5 and D receives 5 as well. So D and B both receive 5 approvals, but A receives 6 approvals. So A is in fact the preference approval winner. So this is an interesting method. It's somewhat complex because there are a lot of conditions you have to check. But it's an interesting method. It would be interesting to look at some more properties of it. Brams and Sandver propose other methods that take into account both the preferences and the approvals of the voters. They have another method called fallback voting. But it might be fun for you to try to come up with your own method that takes into account both pieces of information.